Hello everyone, welcome to tutorial 3. My name is Mehdi. This session we're gonna solve 6 questions. I have selected these questions from your tutorial questions booklet. Let's start the first one for 19. In this question we have a rod under the axial load P. We need to determine the modulus of elasticity or elastic modulus E and Poisson ratio nu. For finding the modulus of elasticity or elastic modulus, because we have a rod under the axial load, we have the axial stress, we can simply write Hooke's law, sigma is equal to E epsilon. E, sigma is the axial stress, epsilon is axial strain, and E is elastic modulus or modulus of elasticity. For finding the sigma, we can write P divided by A. For finding the epsilon, we can write delta L divided by L. Sigma is equal to P over A. In this question, P is equal to 3.5 kilonewton tensile force. 3.5 times 10 to the power 3. Sorry, let me write here. 3.5 times 10 to the power 3 kilonewton to newton divided by the A, cross-sectional area. Cross-sectional area, the original diameter is 15 millimeter. Yes, it's a circular shape. That's why we can write the A is equal to pi d squared divided by 4. 15 squared divided by 4. Sigma is equal to 19.8 MPa. 19.8 MPa. And epsilon is equal to delta L divided by L. The original length, when we are talking about the axial strain in the longitudinal direction, in the vertical direction, you can see the original length in the vertical direction is 120. And elongation in the longitudinal direction based on the question data is equal to 11 millimeter. That's why epsilon here is equal to 91.67 times 10 to the power minus 3. Sigma, we have epsilon. We can simply find E. 19.8 is equal to E times 91.67. That's it. E, modulus of elasticity or elastic modulus is equal to 216 MPa. As you know, epsilon or strain is dimensionless, and that's why the unit of the elastic modulus or modulus of elasticity is the same as stress. Next section, Poisson ratio. You know that the definition of Poisson ratio, or nu, is equal to negative lateral strain divided by longitudinal strain. Longitudinal strain, we already found it, is equal to 11 divided by 120. Lateral strain, it means that the strain in the lateral direction, in the horizontal direction, the contraction of the diameter or decrease in the diameter is 0.62 millimeter. It means that negative 0.62 divided by original diameter 15. Because this is a contraction, it's a negative here. That's why the final answer for nu is equal to positive 451. We found it elastic modulus and Poisson ratio for this member. Now, next question. For this question, we have a member under biaxial loading. You can see we have sigma z here, we have sigma x here, but there is not any stress in the y direction. That's why we can say sigma y at the beginning is equal to 0. The question is that find the change in the length. When we are talking about the change in the length, we are talking about the delta L. Question is that find the delta L AB, delta L BC, and delta L AC. Delta L AB. For finding the delta L AB, because we have the biaxial loading, we have the stress in the x direction for finding the, and also we have the stress in the z direction, we need to use the generalized Hooke law here. Epsilon x is equal to sigma x divided by E minus nu sigma y divided by E minus nu sigma z divided by E. Epsilon z is equal to sigma z divided by E minus nu sigma x divided by E minus nu sigma y divided by E. Because we do not have any sigma y is 0, this part is 0, this part is 0. For finding the epsilon x, strain in the x direction. Epsilon x, strain in the x direction. We can write sigma x 120 divided by 8 elastic modulus is 87 gigapascal. We need to convert to megapascal. That's why we can write 87 times 10 to the power 3 minus nu 0.34 sigma z 160 divided by 87 times 10 to the power 3. Epsilon x in this way is equal to 754.02 times 10 minus 6. This is epsilon x. Epsilon z in this way, if you put, for example, sigma z, sigma x, nu, and E here in this equation, you can find epsilon z is equal to 1.37 times 10 to the power minus 3. Now, we have epsilon x, epsilon z. We can say epsilon x in the x direction is equal to delta L AB divided by L AB The question is that find the delta LAB. LAB is equal to 100. Epsilon x, we already found it. That's why delta LAB is equal to 754 millimeters. For epsilon z is equal to delta L BC divided by L BC. In this way we can say delta LBC is equal to 75. Delta LBC is equal to 1028 millimeters. And finally, for the diagonal AC, using the triangle rule, let me write here. We have, for example, delta LAB here, delta LAB. We have delta LBC. Question is that find the delta LAC. You can see we can write is equal to delta LAB, delta LBC. And delta LAC is equal to 0.1275 millimeters. We found it, the change in the length of AB, BC, and AC. Again, I repeat here, because we have the biaxial loading, we have the stress in the x direction, stress in the z direction, we use the generalized Hooke law. You know that generalized Hooke law is the general formula. For example, if you have just one-dimensional loading like the previous question, for example, sigma y is equal to 0, sigma z is equal to 0, and it is simplified to sigma is equal to E epsilon. That's why when you have two-dimensional or three-dimensional loading, you should use the generalized Hooke law.